Alrighty, so we're still in Chem Live. We're in W13.13. We are going to generate our table. So we have attic, we have basement, we have a scan through. So the first thing when we get scanned through in terms of numbers is this. So because the 25 is a whole number, that has been pipetted, that is going in to my basement. So I'm going to have 25 centimeters cubed here for my V, my M, my N. My M is going to be 0.12 big M, and the ratio of NaOH is 1. So if you want to label these up, this is your NaOH. This has to be our ethane dioic acid, so H2C2O4. Our volume then for this question that is left over is this 18.7 centimeters cubed. And if you read down here, we're calculating the concentration of this. So that suggests that this is the question mark. 18.7 goes here. Ooh, I've got my ratios wrong, haven't I? So our NaOH is 2 and our ethane dioic is 1. Okay, we look for extra info always because they may be in there. There are no other numbers, so we can just leave this blank and we are ready to go. So again, to remind you, we are doing first principle maths to find big M, moles in a litre. We'll always start with our moles in 1,000 centimeters cubed. This W is the pathway we're going to follow. So we always, when we go down, we divide by 1,000. That's going to give us our moles in a centimeter cubed. We're then going up. When we go up, we always multiply. In this case, we're multiplying by a tighter volume. Once we figure out those moles, we're going to use our ratio across the top. We're then going to go down, so we're going to divide by our other tighter volume, and we're going to find how many moles are in a centimetre cubed of that. And then finally, we're going up, so we multiply by 1,000, and that's going to give us our moles in 1,000 centimetres cubed of, in this case, our ethane dioic acid. We then have to convert our moles per litre into grams per litre, so we put our moles on the left-hand side. We will calculate a molar mass from the formulas given, and we will multiply one by the other, and that will help us get our mass. So how do I start? You know now at this point that I always start by saying what this means. So it means that I have 0.12 moles in 1,000 centimeters cubed. We will have to divide that because we're going down this left-hand side of our W. So 0.12 divided by 1,000 gives me 1.2 by 10 to the minus 4 moles. That is in a centimetre cubed. That gets us to this point. We are then going up, so we are multiplying by, in this case, 25. And I just recognize that I didn't tell you that this is the way into our maths. And again, we use every number that is in our table by the time we are done. So when I multiply by 25, I get 3 by 10 to the minus 3 moles, and that is going to be in 25 centimeters cubed. And again, that is a tighter volume, so I always put that in as a recognition. So that gets us to here. At this point, I need to use my ratio. The ratio I'm interested in is a 2:1, and the two equivalents are worth 3 by 10 to the minus 3 moles, so I obviously have to divide that by 2 to give me 1.5 by 10 to the minus 3 moles. And this is in the 18.7 centimeters cubed. Again, that's our other tighter volume. Okay, so we've come across the flat part of our W. We now have to figure out how many moles there are going to be in 1.5 by 10 to the minus 3 divided by 18.7 to give us our moles in 1 centimetre cubed of this ethane dioic acid, or oxalic acid as the old school name was. So 8.02 by 10 to the minus 5 moles in a centimetre cubed. That has gotten us to here, and we finish it off by going up by multiplying by 1,000, and that is going to give us 0.0802 big M. So again, we just have a look at our data table And we can see up here we have 3 significant figures up here, and these here are 3 significant figures. This O is significant because it comes after this O, if that makes sense. Okay, so the last thing that we're going to do is we're going to convert our moles into grams per litre. To do that, we're going to multiply 0.0802 against the molecular mass of our oxalic acid. So to do that, we have a H2C2O4. So it'll be a 1 by 2, it'll be a 12 by 2, and it'll be a 16 by 4. We plug all that into a calculator, it works out at 90. And as you can keep saying, if you just write in the final answer and by accident you write down 89, they are going to take away 1 mark from you for that because you didn't show your answer. Whereas over here, after this calculation, if I had written 89 here, because I've shown them all of my numbers, I think I may have said that wrong now. So here, if I write in 89 without nothing over here, then that becomes a 0 for that section. Whereas if I do my piece of maths and I write down 89 over here, but I've shown them my steps, that is going to be a slip. Okay, but obviously you will be so amazing that you will catch it all on your recheck. Okay, so we're going to turn this into 90. When we multiply that by that, we end up with 7.22 grams in a litre, like so. We then check back to our question, what do we have to annotate? And again, if you're not sure, don't annotate is the advice. So up here we have A is our big M moles per litre. So that is my first annotation if I'm going to make it. And my second annotation for B is grams per litre. Apologies for that. And that's where we end up.